Hello class, I hope everyone is doing well today. I want to continue our work with solving rational equations. So we're going to start off by looking at a few examples. The first one, the quantity of 2 over x plus 4 over 3 equals 2. We learned how to solve equations by clearing fractions, and we're going to do that same process here. If I look at my denominators, they're 3 and x. The least common denominator is 3x. So I'm going to multiply my entire equation by 3x. So I'm going to distribute through my 3x to everything. When I multiply 2 over x by 3x, the x's cancel out and I'm left with 6. When I multiply 4/3 by 3x, the 3's cancel out and I'm left with 4x. And when I multiply 2 by 3x, that gives me 6x. So I can rewrite the equation as 6 plus 4x equals 6x. At this point, it's fairly simple to solve. I'm going to start off by subtracting 4x from both sides of the equation and get 6 equals 2x. Then I'm going to divide both sides of the equation by 2 and get that x is equal to 3. Take a moment to pause this video and write down this example. Now let's look at another example. We have the equation 3/2 plus 4 over the quantity of x minus 1 equals x plus 1 over the quantity of x minus 1. In this case, I'm going to do the same thing. I'm going to look. My least common denominator would be 2 times the quantity of x minus 1. So I'm going to multiply my entire equation by that denominator. When I multiply 3/2 by 2 times the quantity of x minus 1, the 2's cancel out and I'm left with 3 times the quantity of x minus 1, or 3x minus 3. When I multiply 4 over x minus 1 by 2 times the quantity of x minus 1, the x minus 1's cancel out and I'm left with 4 times 2, or 8. Then when I multiply the quantity of x plus 1 over x minus 1 by 2 times the quantity of x minus 1, the x minus 1's cancel out and I'm left with 2 times the quantity of x plus 1, or 2x plus 2. I can now rewrite my equation as 3x minus 3 plus 8 equals 2x minus 2. Now this is pretty easy and straightforward to solve. The first thing I'm going to do is simplify by combining like terms to get 3x plus 5 equals 2x minus 2. Now I'm going to get the x's to one side of the equation by subtracting 2x from both sides and get x plus 5 equals negative 2. And my final step is to subtract 5 from both sides of the equation to get x equals negative 7. Take a moment to pause the video and write down this example. Our third and final example is the trickiest of the three. If I look closely at my denominators, I can notice that I have x squared minus 9. Well, x squared minus 9 can be factored. It's the difference of squares, so it can be rewritten as the quantity of x minus 3 times the quantity of x plus 3. Looking at that, I can now tell that my least common denominator is the quantity of x minus 3 times the quantity of x plus 3. So now I'm going to take my equation and multiply each part by x minus 3 times x plus 3. When I multiply 6 over x minus 3 times x minus 3 times x plus 3. The x minus 3's cancel each other out, and I'm left with 6 times the quantity of x plus 3, or 6x plus 18. When I multiply 8x squared over, I'm going to rewrite my denominator in factored form, x minus 3 times x plus 3 by my least common denominator of x minus 3 times x plus 3. My denominator cancels out completely, and I'm just left with 8x squared. And finally, when I multiply 4x over x plus 3 by the quantity of x minus 3 times x plus 3, the x plus 3's cancel out. I'm left with 4x squared, or 4x times the quantity of x minus 3, or 4x squared minus 12x. Take a moment to pause this video and write down what we have done thus far. Now that I've multiplied each part of my equation by the least common denominator, I can rewrite my equation as 6x plus 18 equals 8x squared minus the quantity of 4x squared minus 12x. I'm going to start solving my equation by simplifying and rewriting it as 6x plus 18 equals 8x squared minus 4x squared plus 12x. I'm going to continue simplifying by combining like terms to get 6x squared plus 18 equals 4x squared plus 12x. My next step is to get the equation set equal to 0 so I can factor and apply the zero product property. So I would subtract 6x and 18 from both sides of my equation to get 0 equals 4x squared plus 6x minus 18. Now before I factor it, I notice that each of my terms have a common factor of 2, so I'm going to pull out that greatest common factor and rewrite my equation as 0 equals 2 times the quantity of 2x squared plus 3x minus 9. Now I'm going to factor my remaining trinomial using the diamond method. So I'd be looking for factors of negative 18, a times c, that sum to 3. After testing several of them, I would find out that I would multiply together 6 and negative 3, because 6 times negative 3 is negative 18, and 6 plus negative 3 is 3. Now I would make my area model, and in the top left corner, put my ax squared term, 2x squared, and in the bottom right corner, put my negative 9. And my other two boxes are going to be filled in with the 6x and negative 3x that I found in my diamond. Now if I start looking at my greatest common factors of each vertical and horizontal pair, the greatest common factor of 2x squared and 6x is 2x, and the greatest common factor of negative 3x and negative 9 is negative 3. Looking at 2x squared and negative 3x, their greatest common factor is x, and 6x and negative 9 have a greatest common factor of 3. So I can rewrite my equation once again as 0 equals 2 times the quantity of 2x minus 3 times the quantity of x plus 3. Now applying the zero product property, I can set each of my factors equal to 0 and solve. So 2x minus 3 equals 0, and x plus 3 equals 0. I'm going to solve my first equation by first adding 3 to both sides of the equation and get 2x equals 3, and then divide by 2 to get x equals 3 halves. My second equation, I'm simply going to subtract 3 from both sides to get x equals negative 3. So at this point I have two solutions, 3 half and negative 3. Take a moment to pause this video and write down this example. Now we have one step left to finish this problem. Remember our common denominator was x plus 3 times x minus 3. Well, our denominator can never be equal to 0 because division by 0 is undefined. So if I set both of my factors in the common denominator equal to 0 and solve, those are my excluded values. So if I do x plus 3 equals 0, x equals negative 3, and x plus 3 equals 0, x equals 3. Now remember, those are excluded values, so that means that x cannot equal them. Since 3 was one of the solutions that we got before, we now know that 3 does not work. It's what's called an extraneous solution. Therefore, our only solution to our equation is x equals 3/2. Always remember to check for extraneous solutions after solving your problem. Take a moment to write down any questions you have about the video, and I will see you in the Zoom meeting shortly.